Okay, let me give you guys some more practice. So use trigonometric substitution to integrate this. So press pause and have a go. Okay, so to do this, your eye should zoom into this complicated square root bit. Okay, now create a triangle in such a way that this complicated square root bit is true. So create your triangle in such a way that that square root bit is true. So create your triangle. If you make this to be x, and if you make this to be 2, then the hypotenuse will have no choice but to become x squared plus 4. So to integrate this, your eye should zoom into this bit here, and then create your triangle in such a way that this statement is true. Okay, so to integrate this, hang on. So to integrate this, your eye should zoom into this square root bit, and then create your triangle in such a way that this statement is true. Well, that will then give you this triangle here, and then from this triangle here, if you look at this, tan would be this. So if you let tan theta to be x over 2, so let tan theta to be x over 2 times both sides by 2, then that will then give you this. So differentiate, so dx will then become this. Okay, and then on a separate occasion, now look at this. Cos theta would be this. So secant theta would be from here down. So secant theta will be the hypotenuse, divided by 2, times both sides by 2. That will then give you this. So now you see the complicated square root bit. We can now put it into this bit here, and then the dx is here. So we can put this into the dx, and then the x squared here, you've got to look at this. If x equals 2 tan theta, then x squared will equal 4 tan squared theta. So you can put this into here. So this whole thing here will then become this. This whole thing here will then become this. Will then become this. So now just tidy this up. Just bear in mind that you've got secant squared here, and this is just secant. So the two won't immediately cancel each other out. You've got one left. You've got one block left. Okay. So just bear this in mind. Hang on. Just bear this in mind. This is to the power of 2. This is 1 really. So tidy this whole thing up. It will then give you this. Okay. So now visualize this. So here factor out the quarter. So factor out the quarter. So take the quarter out, and then visualize the rest as a block of 1 over 10 times a block of 1 over 10 times the secant of theta. So when you look at this, hang on. So here, looking at this one block here, you've got 1 divided by 10. So what does that mean? 1 divided by 10. Well, 1 divided by a fraction is the same as 1 multiplying with the reciprocal. So 1 over tan theta is the same as cos theta over sine. So this block here, 1 over tan theta is the same as cos theta over sine theta. So this is exactly the same as this. This block here is exactly the same as this block here. This, well, visualize this as this. So now tidy everything up. This will cancel out with this, leaving you with this. Okay, so now use substitution. So to integrate this, let u equal sine theta. If u equals sine theta, then du equals this. Then d theta equals this. So now put it into here. So this here will become u squared, and then cos, leave cos as it is, and then d theta is this thing here. So put this into the d theta. So that would then give you this. So the two cos will cancel each other out. Okay, so this thing will then become this thing here, and then cos will cancel each other out. So that will then give you this, and then visualize this as this. Okay, hang on. So now you've got to integrate this. So visualize this as this thing here. Integrate it. It will then give you. Integrate it. It will then give you this. Okay, and then earlier we said let u equal sine theta. Well now we need to put the theta back into this u here. Okay, so this thing here will then become this. Okay, but we're not done yet. There's still more to do. The answers in terms of theta, we need to translate it back in terms of x. But the point that I'm trying to make is that let's go back to all the way up here. Let's go back to all the way up here. Hang on. Let's go back to all the way up here. Hang on. Let's go all the way back to up here. Hang on. So when you are here, rather than doing this substitution thing, integrate it straight away. So when you look at this, train yourself to look. Well, visualize this thing here as this. Sine theta to the power of -2 times cos theta. So this thing here is exactly the same as this thing here. The point I'm trying to make is that train yourself to be able to spot something being the exact derivative of another thing. So here you've got this thing here being the exact derivative of this thing here. So train yourself to be able to spot a derivative within what you're trying to integrate. So this is the exact derivative of this. So to integrate this, so you're trying to integrate this. Well, integrating this is the same as you integrating this. That means you're looking for something in such a way that when you differentiate it, it will give you this thing here. Well, because this is the exact derivative of this, then make your initial guess to be sine theta to the power of -1. Because when you differentiate this, if you make this to be your initial guess, if you differentiate this, it will give you -1. This thing goes down, and then sine theta, the power gets minus by 1, and then you've got to times with the derivative of this thing, which will be cos theta. You see, this is exactly, it's almost exactly the same as this, but you need to make the adjustment. The adjustment being, make your initial guess to be minus sine. Well, the point I'm trying to make is rather than using substitution here, just train yourself to be able to spot that something being the exact derivative of another thing. So that was if you can spot that, then from here you can just skip the whole lot and just jump all the way down to all the way down to here. Okay, so you can just jump straight to here. Well, anyway, I will continue in the next video from here. Okay.